Alright, so here's how we solve the ice cream cone problem. First, we start off with a waffle. It's a circular thing, and we're going to cut out a sector. Okay? So what we have left is this part of the cone. And that's what we're going to form our cone with. Okay, so this part right here on the edge is going to become the bottom of our cone. Okay, and to find the volume of the cone, because that's what we're going to try to maximize, we know that volume equals 1/3 pi r squared h. But ultimately, the question here is what angle is required. What angle do we need to cut out in order to form a cone of greatest volume? Okay, so we need volume to be in terms of theta. Well, since the new circumference of the base of your cone, which is 2 pi r, is equal to what's left over from your original cone, which originally the radius was 4.25. So it was going to be, it was going to be the original circumference, which was 8.5 pi, minus the arc that we cut out, which was 4.25 times theta, whatever that angle might be. This is what's used to create the circumference of the cone. Okay, so I'm going to solve this for r. I get r equals 8.5 pi minus 4.25 theta divided by 2 pi, or 4.25 minus 2.125 over pi theta. So that's what r equals. Okay, squared. But we also need height to be in terms of theta as well. So here is the radius of our cone, here's the height. This piece right here was the original radius of the waffle. So that is 4.25. And we know that r squared plus h squared equals 4.25 squared. So h equals the square root of 4.25 squared minus r squared. And I don't really have room to put that, so let's move it down here. Volume equals pi thirds times 4.25 minus this mess, theta, times the square root, 4.25 squared minus r squared. And now I have volume in terms of theta. And it's just a matter now of taking a derivative, setting it equal to 0, and I'm definitely going to use a calculator to do this. Okay, so I used my TI-89 to do it. If you don't have a TI-89, then you really can just graph it, and if you graph it, it's going to be a cubic function of some sort, and we can just do calculate max to find the maximum, which is something you can do on the calculator section of the AP exam if you need to. The final answer was that theta needs to be equal to 1.15, and that's rounded, and the maximum volume of your cone ends up being 30.94 cubic inches. So hopefully that helped.